Welcome everybody to the ETHDam workshops. We'll be having 20-minute workshops with about 5 minutes of questions for each one up until 6 o'clock. My name is James. I'm going to be running this stage today and tomorrow. First of all, we have Guru from Waku, who, well, I'll let him introduce his own talk. Thank you very much.
Thank you. Yeah, hey guys, I'm Guru from Waku. I am one of the co-contributors and I'm helping Waku reach the developer audience. So yeah, I'm here to help you guys build amazing stuff with Waku. So moving forward, can we have the presentation? Yep.
Is this you? Oh, no, sorry. It's coming through? That's his present. Okay.
Perfect. So moving forward, Web2 communications do not preserve your privacy out of the box. So every time you make an interaction online, be it a chat message or every time you click a button on the internet, your interaction is being eavesdropped by multiple Web2 sharks. And your social graph and private data can be exploited by various centralized gatekeepers, be it search engines or indexing services or any kind of Web2 service. So your messages are linked to your centralized identities like IP addresses. So every time you send a message, your IP address lets a lot more information than you think. It can be the sender and receiver details, the location of the sender and receiver, and also all the private metadata associated with these messages. And this information can facilitate large-scale censorship and surveillance attacks, which can hinder your freedom of speech. And this problem is not specific to chat. It's pretty much with all the use cases like gaming, marketplaces, location sharing apps, and pretty much anything that requires machine-to-machine or machine-to-human communication. So we are solving this exact problem. We are building a family of robust censorship-resistant communication protocols that are designed to enable privacy-focused messaging for your Web3 apps. Waku has 6 main values, the first one being privacy. The whole design and architecture of the Waku network and Waku protocols are privacy preserving. And the second one is the censorship resistance, which automatically comes in with privacy. And the third one is modularity. Waku is not blockchain specific. It can be implemented with any blockchain. It's something that complements a blockchain. It's not at all related to layer 1s or layer 2s here. It's something that can complement a blockchain. And we're also super adaptive, which means that you can run Waku in mobile devices or resource-rich environments like your clouds, VPS, and cluster servers. It's also securely scalable, which means Waku network as a whole can grow according to the requirements of the apps that are using Waku. And finally, we are also DOS protected, which means that all the centralized attacks cannot be carried out over here. So the best part is Waku did it without compromising on the identity and privacy of users. So I'll be talking about it in the upcoming slides. But getting into it, again, Waku is not a blockchain, and Waku is not a chat messaging protocol, but a generalized censorship resistance preserving communication protocol. And it can cater many use cases, starting from gaming to anything communications. Now, looking at the history, it all started in 2013 when the Ethereum white paper was introduced. In the Ethereum white paper back then, we had the holy trinity of decentralized web into 3 segments. The first one being Ethereum for consensus, Swarm for storage, Whisper for communications. And these together formed the Ethereum white paper. But over the years, Swarm and Whisper have disappeared out of the developer conversations. Only the developers who've been in the ecosystem for quite a long time know about it. And Ethereum itself has been misinterpreted to be the communications and storage layer of Web3. So until 2020, 2020, there were not much of teams working on top of Whisper. And in 2020, Waku replaced Whisper in the status app. And today, Waku is trying to evolve as the standard of Web3 communications. When you look at the segments within Waku, we have two segments. The first one being Waku protocols, which developers can use for building amazing apps on top of Waku. And the second one is the Waku network, which is like the backbone of the whole Waku ecosystem. Waku protocols, we have a lot of protocols, but for this specific hackathon, we'd highlight three main protocols, which are our light protocols: light, push, filter, and store. So each of the protocol has a different use case when you're building an app. Light push is used for sending a message into a content topic, and filter is used for subscribing messages from a content topic, and store is a temporary storage for persisting your messages for some time. So I'm sure a lot of you must be hearing content topics for the first time, but it's the way in which we architecture or filter messages within the Waku network. We have multiple content topics, for example, topic A, topic B, topic C over here, and we have multiple peers listening to different content topics. So this is how the whole Waku network is architectured. And when you are developing, you will be setting up a content topic in the form which is given here. For example, your application name, which could be super crypto, followed by your version, which is 1, followed by the content topic name. You can have multiple categories, for example, for notifications, for messages, for friend requests. So you can have more content topic categories. And finally, the type of encoding that you use. So we have most of the documentation that we have uses protobufs. So that's why we have it over here. So about adaptability, we have, as you can see here, Waku can cater something like a cluster which has more resource to something like a browser which has very less resources available. So the light protocols that we mentioned earlier are the ones that cater the resource restricted environments like browsers and mobile phones. And usually at hackathons, a lot of use cases revolve around these protocols. So that's why we wanted to give you more insights about these protocols. And revising the protocols again, light push is used for sending a data into a content topic, and filter is used for receiving data or retrieving data from a content topic, and store is for persistence. Now, when you look at the structure of each and every data packet that is being transmitted or transferred, this is how it should be looking. The content topic, which is going to be the routing mechanism for the data packet to reach the particular person, and then the payload, which carries the message data, and the meta, which takes in application-specific processing prompts, and timestamp, which is basically the time of the message, and finally ephemeral, which takes a true or false value based on your preference of the message getting stored on the network. So if you want the message to be persistent on the network, you should set ephemeral to true. And if it's false, it's going to be evaporative. So it's not getting stored in the network at all. It's truly peer-to-peer. So anyone can run a Waku node right now. We already have a Docker compose command to help you set up a Waku node on your machine. And you can find more about running your Waku node by scanning this QR code. It's pretty simple. It should just take you a few minutes. And to know more about the network specifications, we have a RFC listed on our research website. You can scan this RFC to know more about it. But just to visualize how fast Waku messages can be, this is how fast it is. It starts from Singapore to Bangalore to San Francisco to New York. And this is simulated in a real world testing scenario with a 2 KB size message object. But yeah, this is the kind of efficiency that we are trying to achieve with Waku. Of course, Waku is definitely an early stage developer tool or an early stage project. But yeah, this is on the full run. This is the kind of efficiency that we wish to offer the developers. Looking at the resources, we have 3 main resources that we want to highlight. The first one being our documentation, which is a holy grail of Waku. It pretty much has all the code snippets and everything that you need to build on Waku. And we also have an idea board, which has community curated ideas. We have around 60 ideas from different people in our community. You can also contribute to the idea board if you want to see something built on top of Waku. But if you're going to hack at the hackathon, make sure to check this out because it has a good number of ideas, like building a GitHub on top of Waku and a lot of cool ideas. And finally, the awesome Waku repository, which has links to all the projects from different Waku hackathons. So we did around 5 or 6 hackathons in the last 12 months. So you can find all the projects from these hackathons, around 85 projects from these hackathons in this repository. It can also be a source of inspiration. And we also have previous workshop recordings in this particular repository, and you can find it on GitHub. I also want to spotlight a few projects that we had from previous hackathons. This can be a very good way to validate your use cases before you start building. So the first project is Block IoT, which is basically an IoT system that communicates using Waku protocols. Imagine a Raspberry Pi at your home, which is connected to your smart devices like your, let's say your TV and your appliances. So it's going to be amazing because Waku can also cater a lot of hardware and IoT related use cases. So Block IoT is one of the references that can help you get some inspiration. And the second one is Becamose, which is one of my favorites. So right now, when you use location sharing apps on your mobile phones, it either gets into the centralized stakeholders for transferring the data because everything happens through servers. But Becamose is an example for serverless wallet-to-wallet location sharing. So if you know an Ethereum address of a person who you wish to share your location, you can do it without getting your location into the hands of these centralized stakeholders. We also have a game called Battle of Cards, which is a fun multiplayer WWE game built on top of Waku. And finally, Mr. Fox is one of the recently buzzed projects from our recent hackathons. They've built a privacy-preserving decentralized Web3 AI assistant, which totally decouples your identity from prompts. So, for example, if you're using an LLM, which is available on the internet, each time you send a message to the LLM, it's going to know what the message is, along with the person or the identity of the person who's sending the message. This is a very big risk for someone who's, querying different kinds of prompts, and it can also be crucial for medical-related prompts and a lot of, privacy-demanding prompts. So this is where Mr. Fox uses Waku to decouple the identity from the prompts, so that the LLM doesn't have to know who is sending the message or who is sending the prompt, but it'll just know the data or the payload which is associated with the prompt. So these are the project highlights that I wanted to mention. And again, if you want to know more, we also have a learn section in the documentation. And you can also ask your questions in Discord. But I just wanted to give a quick overview about how to use Waku SDK practically. I was just building this in the morning, so I have like a couple of bugs. Please forgive me for that. But as you can see, the first step is to create a light node, which is already completed once you start the application. And the second step is to discover peers around you and connect to the peers. So that is also completed. And the third step is to set up encoders and decoders, which is completed. Now, looking at the code for the same application, which is running on localhost, this is the specific code that you want to have on the top for initializing your node. Just hit node.start after you run create light node command. So we also have a testing environment for developers. It's called default bootstrap fleet. So you can just pass in this attribute default bootstrap to true if you want to use default bootstrap nodes. So it's basically a fleet that we've configured for development purposes. So once you're done setting up a node, you can go ahead and wait for a successful peer connection. So for that, you can run the function wait for remote peers and pass in the node object. And yeah, that should get your peer connection completed. And after that, you create encoders and decoders. So for the Waku SDK, we don't really have a default set of like some preferred encryption along with the SDK. You are free to use any kind of encryption mechanism or library that you want to use. And for setting up encoders, which is available in the package, you can simply run the create encoder command function, and you can pass in the content topic inside the function with ephemeral as true. So this is where you have to set it as false if you don't want the messages to persist in the network. So once encoders are completed, it's pretty much the same for decoders. You can have create decoder function and pass content topic into it. So this should get all the first three steps completed for you. And once all the three steps are completed, now we are ready to send and receive messages. So let me try sending a hi. Also, be mindful about the disconnection problems at this point with our libraries. So if you keep your application without usage for some time, it sometimes tends to get disconnected, which is understandable for an early stage project. So yeah, this is pretty much how it is supposed to work. You can see that the message is getting sent, and right now I'm running a store query, but if you use a filter query, it should pretty much appear over here. Let me try refreshing it. Yep, so we can see the received data over here. And we don't have clear benchmarks about Waku's, let's say, latency and stuff right now, but we do have some, benchmarks which are not yet guaranteed, but we definitely have some benchmarks. You can check them out at metrics.waku.org. We have the benchmarks public. But yeah, that's pretty much about Waku. I think I'll use the next 5 minutes for some questions if you have any. And if you have more, we can do one-on-one.
Thank you very much. Can we give Guru a round of applause? Does anyone have any questions? I'll come over with the mic. I have one. So a Waku node can easily be set up with like a nice Docker compose command. Are the nodes incentivized in any way? Are they? How are you managing their behavior and making sure they're doing the right thing?
Yeah, incentivization is currently work in progress. We are having our research teams doing their job right now about incentivization. But yeah, we have more than 450 nodes, as far as I know, from today morning, running without any incentivization. So there's definitely some good community revolving Waku already. But yeah, once incentivization is here, we'll probably boost up.
Yeah, very nice. Anyone else?
I have a new question. Can you send any kind of data?
Yes.
Like any kind of file, any?
Yeah. So the reason why we use messaging at times is to, it's a technical definition in a way that the size of the message object cannot be big, but you can definitely send IPFSC IDs or, any kind of content IDs or any kind of data into it. But obviously keeping in mind that the data cannot be too big for the Waku network. So, yeah.
And like how big is too big?
I would say, I think Alvaro from my team can answer this.
We impose a limit of 150 kilobytes per message.
Awesome, thank you. Thanks. Yeah, that answers it.
Cool. If there's one more question, or we can do it one-on-one, I guess. Perfect. Thank you.